with that, we're going to move right on into our next thing here, which has to do with the Ring of Fire. And Patrick is going to tell us what event happened on the Ring of Fire. And Patrick, what went on that we're so interested in that we're talking about an undersea volcanic explosion or something when happened? What went on?
Oh, nothing much. No, actually, a lot.
Yeah.
If you look at this Ring of Fire map, there was some activity going on with an undersea volcano in the southern portion of the Ring of Fire. And you can see way down there near Australia, the Tonga Trench. And that's where we're going to take a look at what happened. In this picture here, this is an image of the volcano Hunga Tonga, which erupted in the middle of last month and with a lot of ash and steam clouds, including lots of volcanic lightning. It was a hub of activity. Now, just exactly where is this place? Well, we saw in the map there, the Ring of Fire is off of Australia. Hunga Tonga is located roughly about 1,200 miles just north of New Zealand. And we're going to just zoom into the area here because there is actually some interesting geological activity that's happening. So what we see here is Hunga Tonga. It's just positioned on top of an ocean plate called the Australian plate. And then to the right is the Pacific plate, the vast Pacific Ocean. So here we're looking at a map of the actual sea floor or the ocean floor. And that arrow from the Pacific plate indicates the direction of motion of the Pacific plate, which is colliding with the Australian plate. If we take a cross section of that area and kind of in a generalized diagram, we can see what's happening. The Pacific plate is being pushed underneath the Australian plate, and there's an area about 50 to about 100 miles below which the pressures and the temperatures increase so much so that the rock begins to melt in the ocean crust. Now it's water rich and the water lowers the boiling point of melting rock. And so this melting rock accumulates in a kind of a giant cavity called a magma chamber. And the hot rock has only one way to go because it's hot and less dense. It goes straight up and goes through vents and eventually works its way up to the top of the ocean crust and forms an undersea volcano, which is the case of Hunga Tonga. Just to take a look at a profile, you can see it is a volcano which is kind of elevated from the sea floor. And you can see that gray area there. That's actually the part of the volcano that's just above the ocean level. That's the visible part. The rest of it is beneath the ocean. This gives you a better view of the actual volcano. It's roughly about 20 kilometers across in diameter, and it's about 1.8 kilometers from the ocean floor all the way up. And that scale on the right there, which indicates the meters below sea level. So all the yellowish and sandy parts are the highest point of that volcano, but the rest of it, the caldera, is deep beneath the ocean level. To get a sense of what it looks like, we can take a look at pictures taken by this satellite, which is owned by the French space agency, the Pleiades satellite. Its orbits roughly at a height of 640 kilometers above the Earth, so it only goes over this area about once a day. And it's been taking pictures of this undersea volcano for a few years now. So we're going to take a look at how it looks. Back in 2014, Hunga Tonga was two islands. And actually, it has two names. The island on the left is known as Hunga high up here, and the one on the right is Hunga Tonga. Both of them are roughly about a mile across. And it really hides, because this is almost like the tip of an iceberg, in this case, a volcanic iceberg, so to speak, that the rest of the volcano is just hidden underneath the ocean there. So this represents a portion of the rim of the volcano that's visible. Now, there had been some activity back in 2009, and that happened on the Hunga high up here island. And then in 2014 to early 2015, there was another major eruption. So much ash and rock was thrown up from this eruption that it settled down and formed a land bridge between these two islands. which is amazing. The bridge is roughly about 1.5 miles across, bridging the gap between these two islands. There was more activity that happened after 2015, and the island grew in size. And then last year, on December 20th, it erupted again. So there's periods of activity, and then there's periods of quietness. Well, last year, there was another eruption that you can see here, and this actually was taken on January 3rd. You can see steam coming from the event, so it wasn't a big eruption, but enough to be visible from the satellite. The eruption continued through to January 11th, and the volcano went quiet again. So geologists thought, well, the volcano has become dormant again, and nothing's going to happen. But then this picture was taken on January 15th, and look what's happened. The middle of the island, 1/3 of it has disappeared. It's collapsed beneath the water and has collapsed towards the caldera of the undersea volcano beneath it. So we got this picture, but the satellite, as I was saying, that only has to fly over this region to monitor it. So it can't monitor it all the time. What can monitor activity is this satellite, the NOAA's GOES 17 satellite, a weather satellite that is in geostationary orbit. That means it sees the same face of the Earth 24/7. And it's programmed to take pictures of the Earth every few minutes just to see the movement of clouds, so we can see what the weather conditions are like all over the Earth. Well, on January 15th, just during its routine picture taking, as it's programmed to do, we saw this, and it just looks like a regular day. But wait a minute, what's going on there?
Oh,
That is the exact location of the Hunga volcano, which literally exploded and actually caused a gigantic plume to be visible from a satellite 22,000 miles away. That's just unbelievable, and unbelievable because it was actually captured for the first time with a satellite in almost kind of real time, but every few minutes a picture was taken to actually capture the eruption of an explosive event that has not been seen by a satellite. All right, there's some more stuff too. Let's go to the Japanese satellite called Himawari 8. And you can, if you look at this, look at the shock wave that is blasted ahead of the plume. And that has never been seen before. This is just totally amazing. So you would think, okay, well, that doesn't look very big, does it? Oh, here's another image. You see it again from a close-up from the Himawari satellite. All right, we'll put this to scale. California, you see Los Angeles and San Francisco. There's the plume.
oh,
Super large. I mean, it just gives you an idea of scale of things when you compare it to land masses here, because out in the ocean, it's vast. Now, the explosion was so powerful, it sent a shockwave blast moving at 700 miles per hour. So that's faster than a jet airliner. And it took hours to cross the ocean. By the time it reached Alaska over 9 hours later, booms were actually heard by residents. The explosion itself, people heard it. It was just, unbelievable. Furthermore, the shockwave actually registered on a buoy out in Nantucket. And you can see in those circles there, those little blips there are sudden increases in pressure. This next image is kind of the map of the shockwave radiating out. And that shockwave circled the Earth 3 times. It was that powerful. Now, from Los Angeles, we wouldn't feel the sudden increase in pressure or anything like that, but instruments were sensitive enough to show this. We could actually see the visible effects of the shockwave from footage taken from webcams at Mauna Kea in different directions. And if you watch very carefully, look for the red wave ripples that occur. They're not there.
Oh, there we go.
Yeah, here it is. Here it comes.
I see it.
So that's from one camera looking in one direction. There's another view from a different camera in another direction. There you see the waves.
There we go. Yeah.
Moving through.
Wow.
Yeah. And that's in Hawaii. That's a long way from Hunga Tonga.
Yep. And so apart from the waves, there was a tsunami just 20 minutes after the eruption with waves up to 6 foot washed across the island of Tonga, which was about 40 miles away, and caused a lot of devastation to the island, which they are still picking up the pieces even today. The wave also continued its journey across the ocean to New Zealand. Parts of New Zealand were hit by 4-foot waves. And this also caused a tsunami alert from National Weather Service for all of the West Coast, and also from other international agencies, such as in Japan and Southeast Asia. Here in Los Angeles, we had our own tsunami advisory, and the waves here weren't too bad. They were just about 1 to 2 feet, and people were told to stay away from the coastal areas until the tsunami advisory warning had passed. So what kind of atmospheric effects came from this? Millions of tons of ash and dust were ejected up into the atmosphere, and some as high as 55 kilometers in height, almost halfway up to the edge of space, which is incredible. The space station saw the ash and cloud move in from their vantage point over large areas of the planet from the Hunga Tonga explosion. This is a particularly dense region of cloud. Even satellites monitored the gases released, which carry the ash and dust. You can see a portion over Australia. And pictures taken of sunrise over Queensland showed very unusual skies as the ash rolled across and caused the reddening of the sunlight as the sun rose. These eerie sights were incredible to see if you were actually there watching a sunrise or even a sunset. What has become of the island? Well, this is a recent picture, since January 16th. All the activity has stopped, but you can see that the island, it looks a lot smaller. And this next image shows you a before and after. So December 8th, the explosion basically obliterated the islands, and you can see only little small pieces of it left over. This is almost a once-in-a-lifetime opportunity. Geologists say that this type of eruption takes place on the order of every 1,000 years. It happened to happen during our lifetimes, so incredible.
Really incredible stuff. Super, super interesting, Patrick. But what were the effects for climate, I want to say? I want to move into that part of the discussion. So looking at that, Earth, of course, is warming up. A lot of people want to say, well, volcanoes produce CO2, and that CO2, as we know, is a climate changing gas. It's going to warm us up. Well, let's look at the billions of tons per year. Global volcanic emissions, they're grabbing the higher estimates, is only 0.26 billion metric tons, whereas humans produce 32.3 billion metric tons. So yeah, it's not even in the same ballpark. It's 0.2 versus 32. So the volcanoes aren't causing the warming, but they can change the climate, actually. These hydrogen sulfides and hydrogen halides, well, they do cause some things, because you can see here, they block out, the sunlight. Will it change the temperature? Well, we know it's not good stuff to breathe, pretty nasty stuff. That sulfur dioxide and ash, as you saw Patrick show, indeed does block the sunlight, and it spreads around and blocks it. But ash is not super effective at cooling things down. It falls down pretty rapidly and doesn't block a lot of the sunlight. But what does is the photochemistry, as that sulfur dioxide interacts, turns into sulfuric acid. That's right, we get acid rain falling out of it, and that becomes a very reflective cloud up in the upper atmosphere. So it turns out that this sulfur dioxide is a cooling agent. It's poisonous too. You don't want to breathe it, not good. And it will cool off the Earth. And you can see here again that eruption injecting material high into the atmosphere, and it could cause cooling. There's that SO2 plume, made its way all the way over to Australia from Hunga Tonga volcano. And well, is it going to cause cooling there in Australia? Probably not. Those beautiful sunsets, yes, it has the effect. This is actually Mauna Loa erupting, which gives off CO2 as well. But the Tonga eruption did not really create a lot of sulfur dioxide. The Pinatubo eruption back in 91, maybe some of you remember, it did cool things down just a little bit. We had beautiful sunsets, and it got a little chillier. It changed the climate, but you can see how much more sulfur dioxide was given off. A lot more was given off in that eruption. So, Chris, how does this compare to Krakatoa? Well, a big one back.
Oh yeah. Yeah, this is an example where these things happen if you live on an active planet, and these things have happened before. And probably the most famous example of this sort of thing happening in the Pacific with a volcanic island deciding to check out is Krakatoa, 27th August of 1883. In fact, a lot of people in the audience probably know vaguely the word Krakatoa, just then maybe don't even know why. It just means something, right? Something bad, something big. Well, it was a huge explosion, bigger even than this one. Now, they have a scale for the volcanic explosivity index, they call it. Uh, the famous Mount St. Helens in 1980 in the Pacific Northwest of the US, that was a 5 on that scale. Then Hungatonga is 5.5 on that scale. Krakatoa was a full 6. It was a bigger deal. Same sort of idea where an island basically explodes, although it was a more deadly kind of explosion, what they call a pyroclastic flow. And because of this, yes, there were tsunamis and everything else, but the explosion was of a more deadly type. And the death toll was much more than what we're looking at today from this event. Latest estimates I've heard from Hungatonga, it looks like maybe 5 or 6 people lost their lives. For Krakatoa back in 1883, the death toll was more than 36,000. It was a huge deal. And like with Hungatonga, the explosion was heard a huge distance away. In fact, with Krakatoa, 3,000 miles away, people heard it. And pressure waves went all the way around the earth. There were tsunamis, all the rest of these kinds of things. Similar to what we've seen this time, but actually a bit more powerful. So this is a good example that these things happen where we just showed pictures of the sunsets where they change colors. The sky can change color. Well, the picture, the very famous picture you've got on the right there, The Scream by Edvard Munch. That picture, it turns out, was painted 10 years after the Krakatoa eruption, but the skies for years in the northern hemisphere were reddish. Everyone noticed this for years and years. And it's a theory that people have. This painting, the red sky behind him, might actually be inspired by Krakatoa. So it enters our culture and our memory. So when we think Hungatonga, remember also Krakatoa, east of Java, 1883.
Wow. So these do happen. This wasn't the largest explosion, but those images that Patrick showed us capturing it from space, unlike anything I've ever seen before, those pressure waves, all the rest, we get an unprecedented view of these things these days.